guys, apologies for not uploading a video up until now. I've been busy on another project as of late. Since finishing the 3D printer, I've been meaning to try some other exotic materials other than PLA and ABS. So I've approached a local filament distributor and I've purchased some samples of him. And what I have in front of us here are two flexible filaments. This white one here is PolyMaker PolyFlex White PLA, they call it. However, it does have a rubber-like consistency and is very flexible, as you can see. Quite grippy as well with texture. Filament, you know, it's quite flexible. It's a little bit stiff, but I think I'm going to have some joy with this. The website does say that this flexible filament is suitable for 3D printers with rep wraps and so on. So I think we'll have some luck with this one. I also have some of this black filament. This is just called Flex TPU. This is a lot more flexible and rubbery than the PolyMaker PolyFlex. So I'm not sure if I'm going to have success with the Bowden setup on my 3D printer. Once again, the texture is definitely like a rubber, quite grippy. There's a little bit of elasticity. I can pull on that filament and it'll stretch and spring back, and it is very flexible. Yeah, so that is almost like a thick rubber band, I guess is probably the closest that I can describe it. So before I go ahead and install this filament in the printer and start printing, I'd just like to remove all of the existing plastic that is in the hot end at the moment before printing with this stuff. So let's go ahead and do that now. And just before I go ahead and clean out the hot end, I've printed a test piece with stock standard PLA plastic. So this will be, I guess, our base test print that I'll be printing with all the other exotic material. So this is just a an optical illusion vase. I downloaded this one off Thingiverse. It is a solid piece, so I've had 0 infill and slicer and just 2 perimeters printed at 0.2mm layer height and 3 bottom layers. So I've scaled it right down so it's nice and small because I don't have a lot of the flexible filament to try. So this is only 4 or 5 grams. I should get a couple of goes out of the TPU and the PolyFlex filament. So this will be our baseline, and let's see if we can replicate this with the other filaments. So to clean out the hot end, first I'm going to dislodge the idler from the Bowden setup. Unscrew that and push that back. The next thing I'm going to do is to remove the Bowden tube from the E3D hot end while leaving the filament still stuck within the Bowden tube. So I'll push down on the clip and pull up the Bowden PTFE tube like so. As I have PLA filament loaded into the E3D hot end currently, I've set the hot end temperature to 110 degrees. That seems to work quite well for the filament that I'm using in what's known as cold pulling the filament. So at 110 degrees I can pull the filament out of the hot end and it'll take all of the filament with it, and we should be left with no filament left in the hot end, and we should be able to see directly down the hot end and see daylight through the nozzle. If I was using ABS plastic, the stuff that I have here seems to work at 150 degrees for this exercise. But once again, it's something that you'll have to experiment with your own filament. So I'll set this to 110, so we should be able to pull the filament out now, and hopefully all of it will come out. Just make sure there isn't any filament oozing out of the nozzle. If there is, make sure you remove that filament first, otherwise that will prevent you from cold pulling the plastic out of the nozzle, and there'll still be some left in there. So as you can tell, there's no filament that's oozed and solidified out of the nozzle, so I can go ahead and pull the filament. Before I go ahead and pull out the filament, I just need to brace the X carriage and also the Bowden mount, so I'm not pulling up the entire Z-axis when I'm pulling out the filament with a below temperature hot end. So I'll go ahead and brace the Bowden mount now, get a good grip on the filament and give it a yank. And there we go, that has pulled out. That wasn't too bad. I'll take a photo of this, but you can just see the shape of the nozzle. So if I look down the hot end, I should see daylight, and yes I can. So I'll take a shot of that now. And here we are looking straight down the E3D hot end. You can see light, that's through the nozzle, so we can be quite confident now that not only is there no plastic left in the hot end, but we've also removed any debris that may have built up in there over time. So this is something that I do quite often just to clean out the hot end whenever I'm changing between filaments. I'll start with the PolyMaker PolyFlex. Now this isn't on a spool, of course, this is just a sample, so I'll be most likely just feeding this through the Bowden while it's printing, just for the purposes of this test. Of course, if you buy a whole roll of this you won't need to, it'll fit on the spool holder. So I'll go ahead and, just like the PLA or ABS, I'll feed this through the bottom of the Bowden mechanism, past the Mark 7 drive gear, and then into the Teflon tube. It's fairly easy. Slides through very easy, actually. I was worried that the rubber material would bind with the PTFE tube, but that's going in super smooth. I've now preheated the E3D hot end to 220 degrees Celsius. That's within the range of the PolyMaker PolyFlex melting temperature. So exactly the same with like an ABS or PLA. I'll feed the filament down the E3D first before pushing down the PTFE tube. So let's do that now. Okay, I can see some filament oozing out of the nozzle, so I can now go ahead and feed down the PTFE tube, push that down until it stops, which is right there, and of course reattach the idler. And just as a test run, I'll see if I can feed through some filament. Seems to work a treat. Cool, let's start printing. So here's the first attempt with printing with the PolyMaker PolyFlex. No issues with the Bowden mechanism extruding the plastic, and no issues with adhesion on the blue painter's tape. But it does look as though I'm getting underflow issues, so I might bump up the flow rate in the slicer, slice this optical vase illusion again, and let's see how we go. And here's the completed optical illusion vase with the PolyMaker Flex filaments. Doesn't mind oozing out of the hot end, this filament, but not to worry, this is quite a nice finish. Here we have the completed vase test piece in the PolyMaker PolyFlex white filament. I must admit, printing with this filament on the Prusa i3 3D printer at 1.75mm filament with the Bowden extruder mechanism was dead simple. All I had to do was increase the temperature to 235 degrees C and increase the extrusion multiplier and slicer by about 15%. And this is the result. Comparing the PLA test piece to the flexible filament, I must say the flexible filament almost looks better, as in the finish. The walls are very uniform compared to the PLA. And if it wasn't for the fact that this was flexible as opposed to the PLA being rigid, you wouldn't know that this was, a flexible exotic type material. So the pros of this is it prints just as easily as PLA filament. So if you can print PLA filament now with your 3D printer, chances are you can print with this PolyMaker PolyFlex. Also, the quality, as I mentioned, is fantastic. So if the finished quality is something that's important to you with also having the flexibility, well then this is the filament to choose for sure. Another plus is, just like the PLA, this sticks to the blue painter's tape on the heat bed very well. No heat, it just printed down at room temperature, and it peels off easily as well. So once the print is finished, I guess because it is flexible, it's very easy to peel off the bed, and the finish on the base is very uniform and also quite nice. The print speed as well. I print the perimeters at 40 millimeters on this, and the infill at 60, which was only the base in this instance. And the PolyMaker PolyFlex was able to keep up at those speeds, so there's no increase in print time. It prints just as easily and just as fast as the PLA. And finally, it just looks like a nice looking part. I'm not sure what it is. I'm not sure if the filament is very precise in its tolerance, so the walls are nice and uniform because there isn't that deviation in the filament itself, or if it's the fact that it is flexible and it just binds itself to the previous layer. I'm really happy with this, and as you can tell, you can scrunch this up into a little ball, and it'll just bounce back into the shape that you had. So if you're after flexible filament on your existing 3D printer, you can't go wrong with the PolyMaker PolyFlex. Okay, let's load up the Flex TPU. This stuff is a lot more rubbery and flexible than the PolyMaker PolyFlex, so let's see how we go with this material. Once again, seems to slide up the Bowden tube without an issue at all, although it does seem to bind a bit more down the base here. I do need to feed it with both fingers, unless I'm careful not to flex it too much. I've preheated the Hotend to 220 degrees Celsius, the same as the PolyMaker PolyFlex. So let's now feed the black TPU through the E3D, see how we go. Okay, I can see it extruding out the base, so now I can feed the PTFE tube. Definitely more flexible than the PolyMaker stuff, but not impossible. Okay, it's loaded. And of course, don't forget to tighten the idler bearing. Okay, let's test extruding some filament. This stuff is quite oozy as well, just like the PolyMaker PolyFlex. Great. Let's do our test print. After a couple of attempts at printing with the black TPU filament, it was evident that I was experiencing some under extrusion in certain areas. Having to increase the multiplier and also having to ramp up the Hotend temperature were sure signs of under extrusion. So in an attempt to eliminate or at least reduce the amount of under extrusion, I've now shortened the length of my PTFE tube. You would have seen in other videos the tube was actually quite long to begin with. It was 70 centimeters. So I've chopped off about 12 centimeters here to shorten the tube. And what I'll do as well is rerun the tube so it's not taking quite a long path. So rather than sort of looping around, I'll try to have it so that the tube is as straight as possible into the E3D hot end. And we'll see if that makes a difference with printing with this extremely flexible black TPU filament. And lastly, we have the Flex TPU black filament. This filament, compared to the PolyMaker, PolyFlex, and also PLA and ABS, was a little bit more challenging to print with. I guess that's what others have been saying about a Bowden extruder mechanism with only a 1.75 millimeter diameter. The really flexible filaments can be a little challenging or problematic to print with, and that's exactly what I experienced. I had to make a few adjustments to the slicer settings to then finally have success with this part as you see it. So the first thing I had to do was increase the temperature of printing. I printed this at 245 degrees C on top of increasing the multiplier, extrusion multiplier and slicer by 15%. And I also had to decrease the print speed from the 40 millimeters a second that I can print this at to down to 20 millimeters a second. So the E3D and the Bowden at 1.75 millimeter really had troubles extruding this Flex TPU filament at a constant rate without under extruding. So if you have to increase your temperature and reduce your print speed, that's a sign of under extrusion, and I've had to overcompensate basically to print this. But that's not saying that's a bad thing, because this part has printed, and it's for me it's a successful print. And just like the PolyMaker PolyFlex, this goes into a ball as well, and it actually springs back a little bit faster. It is actually a little more flexible than the PolyMaker PolyFlex. So if flexibility is your number one factor, well, this Flex TPU is the stuff that you need. Also, something else to keep in mind is this filament. I didn't mention it before. It has a bit of a sticky surface to it. I guess it's just really grippy. So when it was printing, if you have any dust that attaches itself to the filament, it will stay attached to the filament unless you brush it off. So that's something to be aware of. If that dust makes it into the nozzle of the hot end, it may block your hot end, and then you'll have more extrusion issues going forward. What else? Oh yes, in an effort to print this part as I have now, I shortened the PTFE Teflon tube by about 12 centimeters to reduce the length of the filament, from the Mark 7 drive gear to the hot end, just to aid in the extrusion. So I think that is also assisted in completing this part. But just like the PolyMaker PolyFlex and PLA, sticks to blue painter's tape beautifully with no heat, and once the part is finished, it simply peels off. So that was a good touch. But just another thing, the actual finished result of this is nowhere near as nice as the PolyMaker PolyFlex or PLA or ABS, because I'm still having minor extrusion issues. You can just see little ripples along the wall the perimeter of this part. They're only minor and subtle, but they are there. And you know what? This reminds me of my 3D printer, 6 months ago, before I switched over to the Bowden and E3D, where every single part I printed was basically of that quality. So definitely, by not having a consistent extrusion can affect your quality. And I guess when you think about this filament being quite elasticy, and quite flexible like that, it's always being pushed into the PTFE tube and into the hot end. So you're going to have a various extrusion coming out of the hot end, just as there's more and less pressure being applied to the filament. But once again, I'm really wrapped with this material. You can scrunch it up into a ball, and in fact, comparing the PolyMaker PolyFlex to the black TPU, the black Flex TPU is much more flexible than the PolyFlex. That's not saying that's not flexible, of course, but this is, there's almost no strength required to squish this one. This one is a little more rigid, but you can still, of course, scrunch it down into a ball. But yeah, so very happy with the results of the 3D printer. So I'm glad I've been able to print these, because one of the stigmas with this printer is, or with the Bowden in 1.75, is you can't print flexible. So honestly, if you wanted trouble-free, easy printing, PolyMaker PolyFlex, I can highly rate that. The finish is fantastic. It prints at the same speed as a PLA, and you get the flexibility that you want. Otherwise, you can print in this flexible TPU stuff. You just have to pay more attention to your slicer settings and to the physical setup of your Bowden setup. Thanks for watching. Hopefully this video has been helpful for you. If you like this video, give it a thumbs up, and I'll catch you next time.